Hello students, straight back again. Here we're going to go over the PowerPoint for section 4.1, chapter 4, titled Structure of an Atom. As we go through this chapter, we'll look at 4 sections: early ideas about matter, the one we're going to look at today. Then we're going to look at defining the atom, how atoms differ, and a little bit on radioactivity. Our objectives, what you're going to need to know as we complete this section. You're going to want to compare and contrast atomic models of Democritus, Aristotle, and Dalton. These were some of the early things. And then how Dalton's theory explains the conservation of mass. Review vocab, got definition for a theory here. Explanation supported by many experiments is still subject to new experimental data, can be modified and considered successful, can be used to make predictions that are true. So quite a few things about a theory in there. Only one new piece of vocab we're going to get, Dalton's atomic theory. Main idea for this section. Ancient Greeks tried to explain matter, but the scientific study of the atom began with John Dalton in the early 1800s. So, many ancient scholars believe matter was composed of such things as earth, air, water, and fire. Aristotle was one of the people that was involved with this. They thought it could be endlessly divided into smaller and smaller pieces. Democritus, first person to propose that matter was not infinitely divisible, but made up of little particles. He called it tomos, which is where we get the English word atom. Aristotle didn't think that was right. He didn't believe empty space could exist. Aristotle's view went unchallenged for 2,000 years until scientific methods were developed to prove what was going on. There's a table 4.1 that you'd find on page 103 in your textbook. It gives a lot of information about what Democritus and Aristotle had thought. You also have another figure on page 102 in your textbook showing Aristotle's idea of earth, air, fire, and water. So that'd also be a good thing to add into your notes. Then we move into, so that was early Greek philosophers, but go all the way up in the early 1800s, a guy named John Dalton was working, and he developed the first widely accepted atomic theory. And why? His ended up being accepted opposed to others. He had evidence, but it explained the conservation of mass as the combination, separation, and rearrangement of atoms. This table 4.2 you'll find on page 104 in your textbook. Gives the basic ideas of his atomic theory, and you'll want to have these written down. So, brief overview of section 4.1. And read the section, add notes in, anything you feel is necessary. Add a couple quick questions you ought to be able to answer. Who was the first person to propose that matter was not infinitely divisible? And that was Democritus. Dalton was the first to come up with evidence. Aristotle, Plato, we're dealing with the earth, air, fire, and water stuff. And Dalton's explained the conservation of mass. We're going to come on to how the electron was developed, the nucleus, and how we figured that out. And we don't have anything like a law of Democritus, so law of conservation of mass. So there's our 4.1 notes. That's it for now. Till next time.